Have you ever wondered what's really going on under the hood of your computer when you, say, open an app or load a file? Well, today, we're going to pull back the curtain on one of the most vital parts of that whole system. It's memory. Let's get into it. Okay, so let's kick things off with a question that honestly trips up a ton of people. What is the actual difference between memory and storage? I mean, you hear those words used almost interchangeably, right? But they're not the same thing. Not at all. And figuring out why is really the key to understanding how your computer thinks. You know, the easiest way to get this is to use a little analogy. I want you to stop thinking of your computer as a black box full of circuits. Instead, just picture it as a workspace. You've got a desk for your current projects and a big filing cabinet for everything else. Keep that image in your head because it's going to make everything else click into place. So, first up, let's talk about the desk. In the computer world, this is what we call primary memory. It's the surface where you lay out all the documents, all the tools, everything you are actively working on right now. It's all about speed and immediate access. Now, this desk isn't just one big flat surface. Let's imagine it's split in two. On one side, you've got all your active papers, the stuff you're scribbling on and shuffling around. That's your RAM. But on the other side, there's something permanent, like a sealed instruction manual that's bolted to the desk. That's your ROM. And it's just there to tell the computer how to do the most basic things, like, how to turn on. Let's look a little closer at RAM, or random access memory. This really is like the papers spread all over your desk. They're super easy to grab, read, and write on. But, and this is the important part, when you're done for the day and you turn off the lights, poof, your desk gets cleared off. That's what volatile means. The second the power is gone, so is the data. It's temporary by design. And then you've got ROM, or read-only memory. This is that permanent laminated instruction manual. You can't write on it, you can't really change it, and it absolutely does not get cleared away when you turn the power off. Your computer needs it. It reads from it every single time it boots up, just to remember how to get started. It's non-volatile. It's always there. So if the desk is for all your active work, where do you keep, well, everything else? Your old projects, your photos, your music. That brings us to the archive. This is your secondary storage. This is the computer's big, long-term filing cabinet where everything is tucked away safely, even when the power is completely off. Now, this filing cabinet isn't just one single type of drawer. Over the years, we've developed a few different technologies. You've got magnetic storage, which is what you'd find in those older spinning hard drives. There's optical, which you'll definitely recognize, things like CDs and DVDs. And then there's the new kid on the block that's taken over, electronic or solid-state storage. The two big filing cabinets you'll find today are HDDs and SSDs. A hard disk drive, the HDD, is actually mechanical. It has a physical spinning platter, kind of like a tiny record player, and an arm that moves back and forth to read the data. An SSD, a solid-state drive, has 0 moving parts. It uses flash memory, which makes it way faster, way more durable, and a lot more efficient. Okay, so we know where all this data lives, but how do we actually measure it? Let's take a second to talk about the language of data and see how we go from a single on or off switch to, well, an entire digital library. Everything, and I mean everything, in the digital world boils down to this, the bit. It is the absolute smallest piece of information you can have. It's just a simple on or off, a 1 or a 0. You can think of it as the atom of data. Now, a single bit by itself isn't super useful, but when you group 8 of them together, you get a byte. And a byte is a really big deal because it's just enough information to represent one single character, like the letter A or the number 5. And from there, things start to scale up fast. If you take 1024 bytes, you get a kilobyte. Now, that might not sound like a lot these days, but it's enough to store a short paragraph of text. It's kind of the first step up the ladder towards really meaningful information. Next up, we multiply by 1024 again, and that gets us to a megabyte. Now we're in territory you probably recognize. A single MB could hold a photo, a short MP3 audio file, or even a small book. Then we hit the one we talk about all the time, the gigabyte, or GB. That's 1024 megabytes. This is pretty much the language of our modern digital lives, right? A movie might be a few gigabytes, and the storage on your phone is measured in gigabytes. And for a good while, the terabyte was the top of the mountain. A terabyte is a whopping 1,024 gigabytes. A single TB can hold a massive library of high-definition movies. This is the standard size for most new computer drives today. But trust me, it does not stop there. This chart shows just how mind-boggling the scale of modern data really is. After terabytes, we go to petabytes, then exabytes, zettabytes, and all the way up to yottabytes. The amount of information we're capable of storing is it's almost impossible to wrap your head around.
So let's put all the pieces together now. How does your digital workspace, your desk, and your filing cabinet actually function day to day?
It's basically a simple four-step dance. First, you need a file, so you go to your filing cabinet, your secondary storage, and you pull it out. Second, you place that file on your desk, that's the RAM, so you can get to it nice and fast. Third, your brain, the computer CPU, its processor, gets to work reading and changing the data. And finally, and this is so important, when you're done, you have to save your work. That puts the updated file back into the filing cabinet for long-term safekeeping.
All right, let's make this real with a quick little problem. If you remember those old floppy disks, they held about 1.44 megabytes of data. How many individual bytes would that be?
Well, the math is pretty straightforward. You just take 1.44, multiply it by 1024 to turn it into kilobytes, and then multiply that result by 1024 again to get the total number of bytes. And the answer is just over 1.5 million bytes on that one little floppy disk. Kind of wild when you think about it. And that really brings us full circle, back to this core definition. See, the memory unit isn't just one single thing. It's the whole system. The fast desk and the big filing cabinet working together as the total space where all your data and instructions are stored and managed. And that leaves us with one final thing to think about. Right now, we're all pretty comfortable living in a world measured in gigabytes and terabytes, but we are moving incredibly fast toward a future of zettabytes and even yottabytes. What does our world even look like